Hello everyone, welcome back to Diksha Karnataka YouTube channel, and today is Sunday. So today is the time for KPL mock test number 17. So yes, last week we had a holiday, we had given you a holiday. There was no KPL for the last week because there was a Christmas, there was New Year, so all the teachers were busy. You guys were also enjoying somewhat during your busy schedule. So we gave you a chance to revise the chapters. Today we are going to discuss KPL based from the chapters EMI and AC. Right now all the chapters are important, so we will be, as we are doing two chapters every week. Today is the time for EMI and alternating current. EMI is for electromagnetic induction. So those who don't know that, EMI is electromagnetic induction. So electromagnetic induction and AC are this week's chapters. So let's start with our KPL series. The first question is: a magnet dropped into a coil of conducting wire along the axis will fall with an acceleration less than g, equal to g the beginning, and more than g later, equal to g more than g. So what is the question? You have a dropped coil conducting wire along its axis will fall. So there is a coil of conducting wires. It is not carrying any current, but they are conducting current. So for example, you say magnet is dropped through a copper tube. Okay, what will happen when the magnet is falling? Okay, it will try to induce a magnetic field into this coil. Okay, and because of this induced magnetic field, the induced magnetic field will try to repel this magnet, right? So magnet will basically slow down because of the Lenz's law. We know that when the induced magnetism try to oppose the external field, that's why the magnet will slow down. So the acceleration will be less than g. So basically what you are doing, you have a copper tube and you are dropping this magnet. There are beautiful experiments available on YouTube, you can check those out. Okay, when you drop that magnet through the tube, the magnet suddenly appears to slow down. Why? Because of this induced electromagnetic field. Next question: the magnetic flask linked with the coil at any instant t is given by phi is equal to 5t cube minus 100t plus 300. The EMF induced in the coil at t is equal to 2 seconds. So phi is given 5t cube minus 100t plus 300, right? So d phi by dt equals to 5 times 3 t square minus 100, right? So this is the differentiation, this is constant, so it will be 0. So now we have to find d phi dt at time is equal to t is equal to 2, right? So first let us calculate d phi dt, then we will see what is the sign. Okay, so 5 3 5s are 15, t square means 2 square minus 100, so it will be 15 times 4 minus 100, so it will be 60 minus 100, that is minus 40. So d phi dt comes out to be minus 40. Now what is the induced EMF? Induced EMF from Lenz's law and Faraday's law, it is minus d phi by dt, right? Induced EMF is negative of the rate of change of magnetic flux, so it will be minus 40, so it will be 40 volt. So the induced voltage is 40 volts. So if you only solve d phi dt, you remember d phi dt, but if you forgot, there will be extra negative sign, then most probably you will answer the option B, which is not correct. Okay, in this case it is not correct. Correct answer is plus 40, not minus 40. Okay, now next question: 3 pure inductances each of 1 Henry are connected in series. The equivalent inductance of the circuit is. So pure inductances are connected in series. Okay, when inductance is connected in series, their inductance gets added, so the correct answer is 3 Henry. Okay, when they are connected in parallel, they are just like resistances, inductance also gets added, and when they are connected in parallel, they also behave like a parallel combination. So, their inductances gets 1 by, okay, 1 by Leq is equal to 1 by L1 plus 1 by L2 plus 1 by L3, but when they are connected in series, their inductance simply gets added. So, it will be 3 Henry. Now, next question, a current of 4 ampere is set up in a coil of self inductance 200 millihenry. The energy required to set up the consequent magnetic field is. So, the current in the circuit is given 4 ampere, the self inductance is given 200 millihenry, the energy. So, the energy is basically, we know that the energy is given by half L I square. For most of the energy equations are like this, right? Half mv square kinetic energy. We started with kinetic energy, similar formula was there, half cv square in capacitance also. Similarly, half Li square is for inductance, right? For many energy equations are like this. So, 200 millihenry, only thing that you have to be careful about this term, 200 millihenry. Milli means what? Milli means 10 to the power of minus 3. So, you have to convert it into not milli, that is Henry only, right. So, milli is bored, so we cannot use milli anymore, but ampere is fine. So, you will use 4 square. So, this is the formula, just calculate 100, okay. So, 100 times 10 to the power of minus 3 times 16. So, it will be 1600 times 10 to the power of minus 3. So, 3 decimals we have to consider. So, 1.6 joules should be the answer. So, 1.6 joules should be the answer. Unit you know, no need to concern about, because units will be given mostly in the same energy units only. So, only thing you have to consider is the value, calculating the value properly, right. So, 10 to the power of minus 3 means 3 decimals you have to put 1, 2, 3. So, you have to put the decimal here, right. Question number 5. A long solenoid has 500 turns. When the current of 2 ampere is passed through it, the resulting magnetic flux linked with each turn of the solenoid is 4 times 10 to the power of minus 3 Weber. The self inductance of the solenoid is. So, the magnetic flux linked is given by 4 times 10 to the power of minus 3, okay, and the number of turns is given by 500 turns, and the current is two ampere. You have to calculate the self inductance of the solenoid. So, the magnetic flask is phi. So, we know that the self inductance is given by N phi by I. This is the simple formula. N is given 500, phi is given 4 into 10 to the power of minus 3, and I is given 2 ampere, right. So, we have to calculate the self inductance. So, it will be simple 2, so it will be 1000, right. 2 times 500 is 1000 into 10 to the power of minus 3. So, 10 to the power of minus 3 means divide by 1000. So, 1000 divided by 1000 is what? Is 1000. You know, okay, good. So, it will be 1 Henry, not 1000 Henry, okay. So, correct answer is 1 Henry. Now, next question, a coil of copper wire having 1000 turns is placed in a magnetic field B equals to 4 times 10 to the power of minus 3 Tesla perpendicular to the axis of the coil. The cross sectional area of the coil is 0.5 meter square. If this coil turns through 180 degrees in 1 second, then the EMF induced is. So, first of all, you have to calculate the flask. Flask is B into area, right. Flux linked with the coil is B into area. Magnetic field is 4 into 10 to the power of minus 3. Area of the coil is 0.05, right. So, 5 4s are 20, and 0.05 means 10 to the power of minus 3, 0.5 means 10 to the power of minus 2. So, it will be 20 times 10 to the power of minus 5. This is the flux linked with this. Now, if the coil turns through 180 degree in 0.1 second, then the EMF induced is. So, you have to calculate the EMF induced, that is minus d phi by dt, or value of only they have given. So, plus will be there only d phi by dt, but only when it is rotating through a distance of 180 degree in 0.1 second. 180 degree means what? Suppose this is the coil. Okay, it was like this. Now, this is 90 degree, this is 180 degree. So, it rotates from BA to minus BA in 0.1 second, right. So, initially it was, suppose it was like this. So, total flux linked with this is BA. Now, it rotates like this, this is 90 degrees, that is now flask is 0. Now, again it rotates to 180 degrees. So, now the flask is minus BA. So, d phi will be, so d phi will be 2 phi, okay, phi minus minus phi. The initial flask was phi, final flask is minus phi. So, change in flask is phi minus minus phi, that is 2 phi. Okay, this is very very important. So, what is d phi by dt? So, d phi will be 2 times 20 times 10 to the power of minus 5 divided by the dt time is 0.1. So, 0.1 is the time, right. So, it will be 40 times 10 to the power of minus, I think there may be some mistake in the values, as even though 0.4 volt is not coming, it will be 40 times 10 to the power of minus 4. So, it will be 4 millivolt. The answer will be 4 millivolt, not so you can take this as milli and you can answer this as 4 millivolt. Option D is the correct answer, right. Now, next question. If the magnetic flux through a coil of resistance R and having N turns changes from phi 1 to phi 2, then the magnitude of the charge that passes through the coil is. So, magnetic flux through a coil of resistance R and having N number of turns changes from phi 1 to phi 2. So, rate of change in flux is basically flux linked with each coil is phi 1 minus phi is phi 2. So, phi 1 minus phi 2 final flask minus initial flask, phi 2 minus phi 1, okay, and you have to multiply with n because there are n number of turns, each turn has flux linked with this phi 2 and phi 1, right. So, it changes from phi 2 to phi 1. So, d phi will be n phi 2 minus phi 1 and in the magnitude of charge that passes through it. So, what is the induced EMF? Induced EMF is n phi 2 minus phi 1 divided by dt. Suppose that it happens in the time dt. So, d epsilon is d phi by dt, magnitude only we are considering. Okay. So, magnitude is only important. So, we are only considering the magnitude. So, epsilon is d phi by dt. Now, what else? We have to calculate the charge. For that, this is a resistance, right, and you can consider this entire situation to be just a battery, right. So, it is an induced voltage. So, induced battery you can consider this having a potential difference of epsilon. So, what is the current in the circuit? Current in the circuit is V is equal V by R. So, epsilon by R is the current in the circuit. Now, what is current? Current is nothing but dq by dt. So, they have asked you to find this dq. So, this is slightly higher level question, not super simple, but not super difficult as well. If you know the concept, okay, even without solving this you can answer it. Okay. How? I will tell you the shortcut as well. So, phi 2 minus phi 1 divided by R, right, and there was there is a dt here. So, dt you have to add here. Now, this dt cancels. So, dq, the charge that changes is n phi 2 minus phi 1 divided by r, right. So, if you see all the options, okay, you can see this option possibly not correct, only these three options look similar. So, from these three similar options, one of them will be correct, right. Now, which one of them will correct? You know that flask changes with d phi is equal to n phi 2 minus phi 1. So, if flask linked with one coil is phi, flask linked with n number of coil is n phi, right. So, change in flask will be n into phi 2 minus phi 1. So, by only knowing this part you can answer this question, because all of the other options do not have this n into phi 2 minus phi 1 term. So, from that only you can easily guess this should be the correct answer even without solving it, right. So, you have to know partially. If you know partially, then also you can answer correctly. So, this is one of the advantage of KCET exam. Now, next, a circular coil of mean radius 7 centimeter and having 2000 turns is rotated at the rate of 1000 revolutions per minute in the magnetic field of B is equal to 0.5 into 10 to the power of minus 4 Tesla. Then the induced EMF in the coil will be. So, what you have to do? You have to find, first of all, you have to find the area of the circular coil. Phi, we know that phi is basically BA always, right. So, first you have to calculate the area. Okay, what is area? Area is pi r square, right, 22 by 7 into 7 square, that is 7 into 7. So, it will be 7, and this is in meter square, 22 into 7 in meters, centimeter square, because the radius is given in centimeter, right. So, to convert it into meter square, this is in centimeter square. To convert it into meter square, what you have to do? 1 centimeter is 10 to the power of minus 2 meter. So, centimeter square will be minus 4 meter square, right. So, what is the flask? Flux will be 0.5 times 22. Don't bother about the calculations right now, into 10 to the power of minus 8. Minus 4 minus 4, there will be 10 to the power of minus 8, right. So, do not bother about the calculations right now, we will solve it later on. Now, what they have said that total number of turn is 200 turns, 2000 turns. So, total turn is 2000 turns. So, total flask will be 2000 into phi, right. So, total flask is n phi. This is for only one loop. So, for n number of loop you have to multiply it with 2000 turns. So, 2000 into 0.5 into 22 into 7, this into the power of minus 8. This 7 and 22, one of them will cancel. So, do not worry about it. Okay. So, you can calculate 0.5 into 2 is 10. So, 0.5 into 2 is 1, 0.5 into 2 is 1, and this 10 to 3 zeros you can reduce it here. So, 1 into 22 into 7 into 10 to the power of minus 5. So, it is basically 22 into 7 into 10 to the power of minus 5, right. So, this is the phi total. Now, what they are saying, it is also rotating at the rate of 1000 revolutions per minute. So, 1000 revolutions, okay. So, it is rotating 1000 revolution. Okay, with one revolution, what is the change in the flask? Okay, so when it is coming from, suppose it is the initial part, when it is rotating, one revolution means what? RPM, right? So, 1 RPM means what is the change in the angle? So, we have to convert it into radian per second, right. So, what is the radian per second? How can we convert it into radian per second? So, to convert it into radian per second, we have to do 2 pi by 60. 2 pi by 60 is the multiplicative factor that you have to apply to convert it into radian per second. So, this is our angular velocity. Now, what we will do? This 0 will cancel, this will be 3. So, it will be 100 pi by 3. So, this is the omega. So, what we have to do? We have to multiply with this. So, the induced EMF is basically phi omega. Okay, phi total times omega. This is the formula. So you have to put that phi total is 22 times 7 times 10 to the power of minus 5, and omega is 100 pi divided by 3, right. So what is pi? Pi is 22 by 7. So you have to add that here. Pi is 22 by 7. So as I said, one of them will be cancelled, okay, and you can even almost cancel this as 3 2s are 3 7s are 21, almost you can cancel. So there will be one more extra 7 here, okay. So anyway, 7 times 22 is almost 1.54, right. 154 basically. So you will get the answer to be 1.54. Why? 10 to the power of minus 5. So let me solve it a little bit deeper so that you don't get confused. So 7 times 22 is 154, and 10 to the power of minus 5 into 100 is 10 to the power of minus 3. So 100 means 10 square, that is plus 2. Here we have minus 5. So plus 2 minus 5 is minus 3, and it will be 1.54. I think I missed something somewhere, so that is why it will be 1.54 should be the answer, right. So the answer to this question will be not 1.54 volt, but it will be 0.154 volt. Sorry, there is a mistake in this question. 0.154 volt will be the correct answer. Okay, if you increase if you make the magnetic field to be 10 to the power of minus 3 Tesla, then it will correct. Now one of the previous problem I forgot to check, there was a coil of having 1000 turns. So that's why I missed it. I said 4 millivolt. So the question in this case will be not 4 millivolt. It will be, you have to multiply with the number of turns. So there will be 1000 multiplied here. Okay, so that's why I made a mistake. So let's see what we will get. 1000 times 40 times 10 to the power of minus 4. So this will be cancelled. This 4 zeros will be cancelled with 10 to the power of minus 4. So you will get 4 volt. Okay, so 4 volts is the answer, right. So this question was correct. This question is slightly incorrect. So this will be 0.154 volt. Now question number 9, if rotational velocity of the dynamo armature is doubled, then the induced EMF will become half, 2 times, 4 times, unchanged. So the rotational velocity of the dynamo armature is doubled. So in the previous problem, that problem we solved, we see that induced EMF is basically change in flux times omega, right. Now change in flux is constant here. So we can say that if you double the speed, the induced EMF will be doubled, right. It will be just 2 times. Next question, a jet plane having wingspan of 25 meter is travelling horizontally towards east with the speed of 3600 km per hour. If the earth's magnetic field perpendicular to the direction of the motion of the plane is 2 times 10 to the power of minus 4 Tesla, then the potential difference between the ends of the wing. So here we have a plane, very common question. We have a plane and the magnetic field downward is given by 2 times 10 to the power of minus 4. The wingspan is given by 25 meters. So wingspan is 25 meter. So a plane is travelling, and what is the potential difference between these two ends? That is, you have to calculate. The speed of the plane is given by 3600 km per hour. 3600 km per hour, but kilometer per hour is our no use. So first of all, we have to convert it into meter per second. 5 by 18. This is the factor. If you remember it, it will save some time for you. Okay, 5 by 18 is the factor to convert from kilometer per hour to meter per second. Okay, so it will be 36 200. So it will be 1000 meter per second, right. So, this is the speed V. Now, what is the induced EMF? In case we know that induced EMF is BVL, okay. BVL is the formula to calculate induced EMF. So, what is B? B is given by 2 times 10 to the power of minus 4, okay, and V is given by 1000 and L is given by 25 meters, okay. So, 25 to the 50, 10 to the power of minus 1. Why 10 to the minus 1? This 3 and this 4. So, only 1 will left. So, minus 1. So, it will become 5 volt, right. So, this 0 and another 0 and 10 to the power minus are enemies. They will destroy each other, right. So, 5 volt is the correct answer. Do not guess, solve it, easy question. You can score full marks. Next question, a circular disc of radius 0.2 meters is placed in an uniform magnetic field of induction 1 by pi Weber per meter square in such a way that the axis makes an angle of 60 degree with the magnetic field B. The magnetic flux linked with the disc is. So, circular disc of radius 0.2 meters, circular disc of radius 0.2 meters is placed in a magnetic field of 1 by pi Weber per meter square in such a way that the axis makes an angle 60 degree with the B. So, the angle between the axis of the disc and this is 60 degrees. So, you have to calculate what is the basically what we do, we take the component along the perpendicular direction. So, it will be the flux is BA cos theta. Okay. One other way to remember, B and A both are vector quantities, phi on the other hand is a scalar quantity. So, definitely it will be a dot product. So, dot product means definitely it will be cos theta. So, B is given 1 by pi, area is pi r square and cos theta is cos of 60 degrees, right. Pi pi cancels, r is 0.2 whole square, cos 60 is sin 30. So, it will be half 0.04 sorry 0.04 into half or 0.02 Weber. So, 0.02 Weber is the correct answer. Now, next question, two solenoids of equal number of turns have their lengths and radii in the same ratio 1:2. The ratio of their self inductances will be. So, everything is same. We know that self inductance is given by mu naught n square AL, right. So, if the everything else is same, equal number of turns have their lengths and radii in the same ratio. So, everything is same, then radii are in the ratio of 1:2, they are self inductance. Okay. So, number of turns is same, length is same, only thing that is changed is the area, right. So, area is different. So, how they are related to area. So, only thing that we can say that self inductance is proportional to area or self inductance is proportional to pi r square. So, it is proportional to the square of the radiuses. So, we can say that L1 by L2 is equal to R1 square by R2 square, right. So, the first radius is 1, the second radius is 2, so it will be 4. So, L1 is to L2 will be equals to 1:4. Very interesting but easy question. Okay, only the thing that you have to remember this formula. If you remember this formula, you can solve this question. Now, next question. A rod of length 2 meters slides with the speed of 5 meter per second on a rectangular conducting frame as shown in the figure. There exists a uniform magnetic field of 0.4 Tesla perpendicular to the plane of the figure. The resistance of the rod is 3 ohm. The current through the rod is. So, first you have to find the current through this rod. This is a little slightly higher order question. So, we know that induced EMF is BVL, this much is clear, right. So, induced EMF is always BVL, L. What is B? B is 0.04 sorry, V speed is 5 and the length of the wire is 2 meter, right. So, 5 2s are 10, 0.04 into 10. So, it will be 0.4 volt. So, epsilon is 0.4 volt, that is the voltage. Now, what you have to do? You have to calculate the current. So, current is basically voltage by resistance. So, 0.4 divided by 3. So, it will be 0.133 something like that. So, or you can say that 133 milliampere. Okay, 133 milliampere. So, correct answer is 133 milliampere. Milliampere means divided by 10 to the power 3 or multiplied by 10 to the power minus 3 or divided by 1000. So, that is how you can say this is 133 milliampere, right. Next question, the time taken by AC of 50 hertz in reaching from 0 to the maximum value is. Okay, so, AC of frequency 50 hertz. So, AC is 50 hertz. So, basically 50 hertz is a representation of to the power second minus second to the power minus 1. So, in 1 second it oscillates 50 times, right. In 1 second it oscillates 50 times. So, how much time it is taken to oscillate one time? So, to oscillate one time is represented by time period. Time period is basically 1 by 50. Okay, 1 by frequency is also known as time period. Time period represents how much time it takes to oscillate complete one complete cycle. Now, in one cycle, how does it oscillate? It oscillates like this. It oscillates like this. So, first it will start from 0, it will reach to the maximum, then again goes back to 0, then it will reach minimum, then again it goes back to 0. So, it has said that how much time from 0 to the maximum. So, how much time? If total time is t, you can divide it into 4 halves, 1, 2, 3, 4, right, and each half takes equal amount of time. So, the time taken to reach from 0 to maximum is basically t by 4. So, it will be 1 by 4 times 1 by 50, that is 1 by 200. Okay, 1 by 200 means 5 by 1000, or you can say 5 times 10 to the power of minus 3 second. So, it will be for an AC to reach from 0 to 100 with 50 hertz, it takes 5 times 10 to the power of minus 3 seconds. Next question, an alternating voltage of frequency 50 hertz is fed to a circuit having resistance of 628 ohm and inductance of 2 Henry. Phase angle between the current and voltage. So, you have to find the phase angle in a LC circuit, LR circuit, right. So, first you have to calculate what is the XL, right. First you have to calculate the XL. XL is equals to 2 pi f times L. So, what is 2 pi f times L? 2 pi into 100 into 2. So, it will be 400 pi. 400 pi is the XL, and our resistance is 628 ohm. Okay. So, 628 is the resistance. Now, you have to calculate the phase angle between the current and the voltage. So, phase angle between the current and the voltage, if theta or say phi, then tan phi is given by XL by R. Okay. So, XL by R is the phase angle formula. Now, what you have to do? You have to put the values 400 times 3.14 divided by 628. So, I made a mistake here, frequency is not 100, it is 50, right. So, that is why answer is not coming. So, it will be 50, right. So, it will not be 400, it will be 200 only, right. So, 100 into 2 is 200. So, now insert the values here. $200, 3.14 is basically 3.14. If you multiply it with 2, you will get 6.28. So, you can cancel this with 200. So, 200 times 3.14 is 628. So, you can cancel them, everything will be cancelled. So, it will be 1. So, phi is 45 degrees, right. So, this is the formula. Now, next question, the value of alternating voltage V in the given circuit will be. So, here they have given you this circuit 80 volt, 40 volt, 100 volt, and they asked you what is the value of V in this case. So, this might be appear simple that okay, there are voltage drops. So, we have to just simply add them to get the value. If you just add them, then you will fall for the trap. So, we know that if you remember that Z is basically square root of R square plus XL minus XC whole square. Similarly, for voltage also it is same formula, okay, VR square plus VL minus VC whole square, right. This is the formula that you have to apply. Now, what is VR? VR is 80. So, 80 square means 664 is 00, right. This is 80 square. Now, what else? VL minus VC. VL is 40, VC is 100. So, VL is 40 minus 100 whole square. So, that is again 6400 plus this is 60 square, right. So, it will be 6400 plus 3600, okay, or you can take this 100 common. So, it will be it will come out of the square root, right. You will take 100 common. So, you will get 64 plus 36. So, 100 square root is what? 10, and what you will get? 36 plus 64 is another 100. So, its square root will be another 100. So, it will be 100 volt. So, the answer is 100 volt, not 220 volt. It is very typical for you to think that okay, 80 plus 20 120, 120 plus 100 220. So, it is a common household voltage that we are getting. Actually, it is not, okay, and unfortunately they have not given the 220 option. This is from one of the previous year question. So, they have not given the 220 option, but in the final exam definitely they will give you the 220 option. Next question, the resistor and the capacitor are connected in series with an AC source. If the potential drop across the capacitor is 5 volt and that across the resistor is 12 volt, the applied voltage is. Now, this is an interesting question. So, again we know that V is equal to VR square plus VL minus VC whole square. Now, VL is 0 here. So, only thing that is left is VC. Again, do not simply add them or subtract them, that is not correct, okay. They have magnitude, they have some value. So, you just cannot simply do that. So, what you have to do? You have to do it like old ways. So, 144 plus 25, that is square root of what? 169, which is equals to 13. So, V is 13 volt. Do not simply add or subtract, okay. This is a simple question, again similar question, but in this case inductor was missing. In a series resonant RLC circuit, the voltage across R is 100 volt and the value of the R equals to 1000 ohm. The capacitance of the capacitor is 2 times 10 to the power of minus 6 farad. Angular frequency of AC is 200 radian per second. then the magnitude of the potential difference across the inductance of the coil. Long question, let us divide it into parts. So, in a series resonant RLC circuit, so resonance, so it mentioned that it is a resonance circuit, there is R, there is L and there is a C. Circuit is resonating. What is the meaning of resonance? Resonance means XL equals to XC, right? This is the condition for resonance. Now, what else they have said? The voltage across R is 100 volt, voltage across R is 100 volt, the value of R is 1000 ohm. So, value of R is 1000 ohm. This is also given. The capacitance of the capacitor is 2 into 10 to the power of minus 6 farad. So, the capacitor is 2 into 10 to the power of minus 6 farad. Angular frequency of the AC is 200 radian per second. So, angular frequency means omega. So, they have given you omega 200 radian per second, right. Then the magnitude of potential difference across the inductance coil. So, they have asked you to find the magnitude of potential across VL. Now, a very interesting question, they have given you voltage across the resistor, they have given some information about the capacitance, they have not given you any information about the inductance and they asked you find the VL. Okay. But they have also mentioned that the circuit is in resonant condition. So, in resonant condition we know that XL equals to XC and also VL equals to VC. So, voltage drop across capacitance will be same as voltage drop across the inductance. That is the beauty of resonance circuit. Now, VL equals to VC means if we can find VC, the same value will be of that of VL. They have definitely of different magnitude. If this is plus, this will be minus. If this is minus, this will be plus. But in this question, they have only asked you to find the magnitude. So, do not worry about the sign. We will first try to calculate VC. The same value will be that of VL. Right. So, basically our objective is to calculate VC, that is the question. How to do that? So, first we will calculate what is XC. XC is 1 by omega C, right. XC is 1 by omega C. Omega is given 200, C is given 2 times 10 to the power of minus 6, right. So, this 10 to the power of minus 6 will go up. So, 10 to the power of plus 6 divided by 400, or you can write this as 10 to the power of 4 divided by 4, okay, or you can make it 100 by 4 into 100, or this will be 25. So, XC is 2500, right. You have calculated XC, easy. Now, what you have to do? You have to find the current. If you can find the current, then you can find the XL or XC, sorry, you can find the VC. So, what is the current in the circuit? Current in the circuit is basically, you know the value of resistance, you know the value of voltage drop across the resistance. So, current in the circuit is basically VR by R. This Ohm's law, our old friend Ohm's law, VR is 100 and R is 1000. So, I is 0.1. So, I is 0.1. So, what is VC? VC is I into XC. So, I is 0.1, XC is 2500. So, it will be 250 volt. So, answer is 250 volt. Next question. In the series LCR circuit shown, the impedance is. So, they have asked you to simply find the impedance. They have given everything, even the frequency is given in a good format. If you see, the frequency is given in a good format. So, is very easy question. First we will calculate. R is given. What is the value of R? R is 300 ohm. Okay, we will calculate XL. XL is 2 pi F into L. So, 2 pi F is 50 by pi, and what is L? L is 1 Henry. Very simple, easy question. If you are afraid, this kind of questions are easy to answer. So, this is 100 ohm. Okay, unit of XL and XC are always ohm. What is XC? XC is 2 pi F C, what is 2 pi times 50 by pi. So, 50 by pi helps a lot because the pi cancels. What is C? C is 20 microfarad. Microfarad means 10 to the power of minus 6. Okay. So, it will be 10 to the power of minus 6, it will go up 10 to the power of 6. 50 times 20, 50, 5 into 10 is 10 and 00, right. So, 100. So, 10 to the power of 6 divided by it will be 1000. So, it will be 1000. Okay. So, this is 1000, right. 5 to the 10, 10, 1000. Yes. So, this is 1000 XC XL. So, what is the impedance of the circuit? Impedance of the circuit is basically given by square root of R square plus XL minus XC whole square. So, let us put the values. So, Z is equals to square root of 300 whole square plus XL minus XC is 1000 minus 100 whole square. So, it will be square root of 300 square plus 900 square. Okay. Now, what else? Well, I made a mistake here. What mistake I made? I ignored this 2 here. So, if I do not ignore this 2, 50 to the 1000, right, but there is a 2 also here. So, this 2 will be here and it will be 20, and the instead of 1000 it will be 2000, and instead of 1000 XC will be basically 500, right. So, XC will be 500, and similarly here also 500 will be the answer. Here also we will change. So, 500 minus 100 will be 400. Okay, you have to check. In case you do not find any matching answer, you have to stop and just check once your calculations, right. So, now you can take this 100 square common. So, 100 square common, it will come out of the square root and it will become 100. This is a sense, this is a sensible answer. Okay. If you take the 100 square out of the square root, it will be it will just be 100, right. Now, 3 square plus 4 square. Now, you know the answer. 3 square plus 4 square square root is basically 5. So, 5 into 100 is 500. So, 500 ohm is the answer, right. Next question. AC supply is represented by 141.4 sin 100 T is applied to a series circuit of impedance 50 ohm, where the resistance has a value of 40 ohm. The circuit is behaving capacitive. The RMS current in the circuit is. So, first of all, the impedance is given, okay, and does not matter what is the resistance, how the circuit is behaving. The impedance itself is given, that is Z is given, okay, the voltage is given, and they have asked you to find the RMS value of the current, which is very simple. First, what you will do, you will find the current in the circuit. So, current in the circuit is basically V by Z, that is 141.4 divided by 50 into sin 100 T. This is the current. Now, what is IRMS? IRMS is basically this maximum current divided by root 2, right. So, 141.4 divided by 50 into root 2. Root 2 is what? Root 2 is 1.41. So, 1.41 is the root 2's approximate value. So, you can cancel this to be 100. So, 100 by 2. So, IRMS is 2 ampere. Now, let us move on to the next question. A multimeter reads the voltage of certain AC source as 100 volt. What is the peak value of the AC source? So, multimeter reads the voltage of 100 volt means multimeter always reads the RMS value. So, IRMS is basically 100 volts. Okay, what is the peak value? If peak value is I naught, then we know that I naught by 2 is the IRMS, that is 100 volt. So, I naught will be root 2 times 100. Now, what is root 2? We just did it in our previous problem, 1.41 times 100. So, 141 volt is the peak value, 141.4 to be exact, but that is fine as long as we are doing it correctly. You can answer this, right. Next question, a capacitor of capacitance 10 microfarad is connected to an AC source and an AC ammeter. If the source voltage varies as 50 root 2 sin 100t, the reading of the ammeter is. So, capacitor of capacitance 10 microfarad is connected to an AC source and AC ammeter. If the source voltage is varies as so why in this case frequency is not given, but so only a capacitor is given and a battery somewhere is given and AC battery is given. So, what they have asked you is the reading of the ammeter, nothing about the current is given. So, first we have to remember that current is basically voltage divided by impedance in case of AC circuit, right. In case of AC circuit it is simply the voltage divided by impedance, voltage divided by impedance. Now, this is since only capacitor is connected in this circuit, so impedance is basically XC, impedance is only XC, there is no R, no XL, so square root of everything will be cancelled, so you will get Z equals to XC. So, these are the smart things. Now, what is XC? XC is 1 by omega C, right, or 2 pi FC, but pi is not given, 2 pi is not given, but they have given you this value sin omega t. So, omega t means omega is 100, right. So, 100 is given, 1 by omega is 100, and what is C? C is 10 microfarad, 10 microfarad means 10 to the power of minus 6. So, as I say micro, from micro it will become milli, right, 10 to the power of minus 3, 1, 2, 3, 3 zeros are here, 10 to the power of minus 6 are here. So, it will become 10 to the power of minus 3. Now, everything is in denominator. So, it will go up and it will become 10 to the power of 3, that is 1000 ohm. This is the impedance, right. Now, what is current? Current is simple, maximum value of current is the reading of the ammeter will be, this is the maximum value of the current. So, there are two more steps involved. What are those? So, first you have to find the maximum current. What is maximum current? Maximum current is maximum voltage divided by the impedance. So, maximum voltage is 50 root 2, 50 root 2 divided by the voltage, voltage is 10 to the power of 3, this is ampere, or 50 root 2 into 10 to the power of minus 3 ampere, or 50 root 2 ampere. So, this is the maximum value of the current, but an ammeter can measure only the RMS current. Any device, ammeter, multimeter, voltmeter, whenever they are connected in the series, they can only measure the RMS value. So, RMS value means you have to convert it into RMS value by dividing it with the root 2. So, 50 root 2 divided by root 2 milliampere. So, this was 10 to the power minus 3. So, that is why it is milliampere. So, it will be 50 milliampere, 50 milliampere is the answer, right. So, this is an easy answer, even you can guess this answer even if you do not solve it, mostly it will be, but you have to find the Z. If you find the Z, then it becomes easier to guess. When 100 volt DC is applied across a coil, a current of 1 ampere flows through it. When 100 volt 50 hertz AC is applied to the same coil, only 0.5 ampere flows. The inductance of the coil is. So, first we have a coil. Okay. Coil, this coil can be represented into two parts. What are those? One resistance and one inductance. coil will have an inductance as well as a resistance. Now, when you are sending the DC current, 100 volt DC current, only the resistance is acting. Okay, for DC current there is no inductance, inductance is 0. So, for DC current we can calculate what is the resistance of the coil. What is the resistance of the coil? V is equal to IR. So, R is equal to V by I, right. Voltage is 100 volt you applied and the current on the circuit was 1 ampere. So, resistance of the coil is 100 ohm, right. So, this is the resistance of the coil. Now, when you apply voltage of 100 volt, but 50 hertz, then what happens? There is a inductance as well. So, XL and XL and R both are acting on the AC current, right. XL and R both are acting on the AC current, and this you cannot simply add XL and R. What you have to do? We have to calculate the impedance, and impedance is given by square root of R square plus XL square. Now, what is XL? XL is easy, 2 pi f L, right. So, 2 pi f L, you have to put the values. 2 pi into 50 into L is not given, we are trying to find L. So, 100 pi L. So, now you have to put these values here to calculate the Z. What is Z? Z is square root of R square, R is 100 square plus 100 pi L whole square. So, what we will do? We will take this 100 square from both terms common, and that will come out of the square root. So, it will become 100 square root of 1 plus pi L whole square. This is the impedance. Now, what we have to do? We have to calculate the current through the circuit. Now, voltage is same. So, the current in the circuit will be V by Z. So, 100 volt applied. Now, Z is 100 square root of 1 plus pi L whole square, right. So, this will cancel, you will get 1 here, and the current in this case is given 0.5 ampere. What else we can write for 0.5? We can write 0.5 as half, right. Half is 0.5. So, now we will take the reciprocal in the both cases. So, we will get square root of 1 plus pi L whole square equals to 2. Now, do the square of both side. If you do the square of the both side, you will get what you will get? You will get 1 plus pi L whole square equals to 4, right. So, this is very, very important. Many students I have seen, they know the thing that what is the question, but while adding that they simply add R and XL. That is not the way to do it. Okay, this is KCET, this is not your PU board exam that you can simply do that. Okay, this kind of problems will not come in KCET always. So, pi L whole square equals to 4 minus 1, that is 3. So, pi L equals to square root of 3, or L equals to root 3 by pi. Very interesting question, root 3 by pi Henry, right. Now, next question. In the following circuit VC for 40 volt, VC is 40 volt, then VR and the current are approximately. So, they have given you what they have given? They have given the input voltage is 50 volt, input frequency is 50 hertz. They have given you VC as whatever the value, VR you are trying to calculate, and you are also trying to find the current in the circuit. So, is it a very difficult question? We have to calculate impedance, etc. Actually not. This is a very simple question. We know the fact that input voltage is basically VR square plus VC square. This is the simplest formula that we are going to apply. Now, V is given, that is 50, right. So 50 square equals to VR square plus VC square. What is VC? VC is given 40 volt. Right, we have squared both sides. So 50 square minus 40 square equals to VR square, or VR square equals to 2500 minus 1600, that is 900. So VR is basically 30 volt, right? So we have calculated VR. Now we just need to calculate the current in the circuit. How to calculate the current in the circuit? That is also easy. Current is very simple, VR by R, our old Ohm's law friend. So VR is 30 volt and R is given 60 ohm. So it will be 1 by 2, or 1 by 2 is 0.5 ampere. So 30 volt 0.5 ampere is the answer, right? Next question. An ideal transformer has turn ratio of 10. Then what is the primary, when the turn ratio means primary by secondary, right? This is the turn ratio. This is 10. When the primary is connected to 220 volt 50 hertz AC source, the power output is. Now here they have mentioned ideal transformer. Ideal transformer means whatever power you are giving to the transformer, the same amount of power you are getting back from the transformer. That means power, input power should be equals to output power. So does not matter what is the turn ratio, what is the voltage, what is the current, as long as it's an ideal transformer, it is working perfectly. Power wise it will be same, voltage will change, current will change, turns obviously you can change based on the requirement, but power will always remain constant. Power is the basically energy, right? Is a form of energy per second, energy spent per second. So energy is a conserved quantity. So power will also be conserved, right? Power cannot, unless and until you are wasting some of the energy due to other losses, the power will always be constant. So output power will be equal to the power input. Next question. In an LCR circuit at resonance, the current is minimum, the current and voltage are in phase, the current leads the voltage by pi by 2, the impedance is maximum. In LCR circuit at resonance, current is maximum, okay, current and voltages are in phase, okay, the current and voltage phase difference is 0, obviously in phase means phase difference is 0, the impedance is minimum, only the resistance works, circuit becomes completely resistive, right. So this is the easy question. The average power dissipated in a pure inductor is. So average power dissipated in a pure inductor is 0. It is not half Li square. Half Li square is the power dissipated when inductor is connected in a DC circuit, right. But average power dissipated when you are considering AC power, okay, average power dissipated in a pure inductor is always 0. Next. An ideal transformer, the voltage and the current are in the primary are 200 volt to 2 ampere, and that in the secondary are 2000 volt and I ampere. The value of I is, so as I said, power dissipated in a ideal transformer is always same. So what is input power? Power is basically Vodafone Idea. So power, input power is 200 times 2. That is input power. What is output power? Output power is output voltage times output current. Secondary means output, primary means everything related to input, right. So 0, 0, 0, 0 cancels. I can cancel one of the 2's, so 10. So 10I equals to 2, or I equals to 2 by 10, that is 0.2 ampere. So 0.2 ampere is the current in the secondary, that is value of I. A step down transformer reduces the voltage of transmission line from 20 to 100 volt to 220 volt. The power output is 880 watt and its efficiency is 88%. The input current is. So now in this case, this is not an ideal transformer. this is a practical transformer and it has an efficiency of 88%, very good transformer. Okay, the power output is given 880 watt. So, if the input power, suppose the input power is P in, then the output power will be, what is the meaning of efficiency 88%? If input power is say P in, then output power will be 88% of that, right. So, this is the meaning of 88% efficiency. Now, the power output is already given 880. So, this is actually 880. Now, we have to calculate power in from this. So, power in is equal to 880 into 100 divided by 88. So, 10. So, power input is 1000 joules, okay, watt, sorry, power input is 1000 watts. So, we have calculated the power input. Now, input voltage is 2200 volt. So, power input from the formula should be primary voltage into primary current. So, primary voltage is 2200 and input current we do not know, we are trying to find the input current, right, and this is equals to 1000, right. So, IP will be equals to 1000 divided by 2200, right. So, it will be 10 by 22, or what you can do, you can multiply with 550 by 110, okay, 110. So, it will be 5 by 11. 5 by 11 is almost is equals to, so what you can do, you can just do the division. 5 by 11, so 0.50, so you just add a point here, 4 ones are 44, so 6, again you will get 60, 555, it will continue, right. So, 4.454. So, it will continue. The correct answer is option D, 0.4 ampere. From the given options, this is the correct answer, no other answer is correct, right. This is easy. Next question, a step down transformer has 50 turns in the secondary and 1000 turns on the primary. If the transformer is connected to 220 volt 1 ampere AC source, what is the output current of the transformer? So, we know that first of all, in case of, you can directly calculate the current, you do not need to wait too much. First you calculate the input voltage, output voltage, then calculate current, that is also fine, but we have other ways to do that. That if we know the current directly, we can say that IP divided by IS equals to NS by NP. Generally, for input voltage, Vp by Vs equals to NP by NS, right. For current, it actually opposite. So, let us see. So, IP primary current is 1 ampere, input voltage means connected to, means it is the input voltage and input current. So, 1 ampere is the primary, IS we are trying to find the output current, right. NS is the turns in the secondary, is 50, and NP is the turns on the primary, that is 1000. So, 0 0 cancels, 5 ones are 5, 5 20 is 100. So, you do the cross multiplication. So, 20 equals to IS, or IS equals to 20 ampere, right. So, 20 ampere is the correct answer. Now, you should remember that if it is a step down a transformer, output current will be higher than the input current. If it is a step up transformer, then output current will be less than that of the input current. So, if voltage increases, current decreases, if current decreases, if voltage decreases, current increases, if voltage increases, current decreases, so vice versa, right, because total power is constant. I hope you enjoyed today's session. I will be back with more videos in our channel soon. Till then, bye.